traversed. Next you have padding. Okay, header must always be in a specific limit, and that also in multiples of your 4. It should be in like a 4 byte boundary. So in case if it is not there, extra bits are padded. Extra bits are padded and added. Next is maximum transmission unit. Okay, usually the maximum size of our IP datagram is 65,000, but the data link layer generally imposes a limit that is much smaller. Okay, so Ethernet frames, they have maximum payload of 1500 bytes. Okay, so this we should take care of the maximum transmission unit, and for Ethernet it is generally 1500 bytes. For a Wi-Fi it is almost set to 1500 bytes. For 802.3 protocol it is 1492. Next is IP fragmentation. The maximum transmission unit is the size in which your host or sender receiver can hold. If your size of the datagram exceeds that, your datagram will be split into smaller units. Okay, so that is called as your fragmentation, and the fragmentation is done in entire path. Okay, because in your path you will have n number of hosts, your interconnecting devices. So fragmentation will happen at each place. Okay, so IP router splits the datagram into several datagram, and fragments will be assembled at only the receiver. It's the responsibility of the receiver to take care of all the data and assemble in the correct manner. So where is fragmentation done? It is always done in the sender, and it can also be done in the intermediate routers also. And the same datagram can also be fragmented several times when it goes through your the entire path, and only in your destination the original datagram will be done. Okay, it will be reassembled. Now what are the bytes or the flags which are involved in fragmentation? That is the total length, your identification, your DF, MF, that is do not fragment, and more fragments, and your fragment offset. Okay, so identification is the nothing but the identification which comes from a host. Next you have do not fragment bit. It says that the datagram cannot be fragmented, and you can discard it if it is too small. And if MF bit is set to 1, it says that datagram is a part of a fragment, and an additional fragment will definitely follow this one. Next, fragment offset. Okay, fragment offset is usually 0, 1, 1. And next is the total length. Total length is nothing but the current fragment's length. Okay, so in case if you have a datagram with a size of 2400 bytes, and it must be fragmented according to the maximum transmission limit of 1000 bytes. So as given in the slide, this is how your data will be split. It will be fragmented. Header length is fixed. Header length is always fixed in all the fragments. Your data length alone you can modify according to your maximum transmission unit. Okay, and this is IPv6 header format. Okay, okay, so it is like an extended version of IPv4 but much simpler. Okay, so here also you have the version, you have traffic class, your flow label, your payload length, that is your data length, your header, your hop limits, and your source ID and your destination ID. Here it is of 128 bits. Okay, so here the headers have fixed size. Okay, IPv6, as I said before, it has a much simplified header structure. Okay, and it has a fixed size. No fragmentation is here. And for error correction, we don't have any error corrections like, for example, checksum. Okay, so moles fields are almost same like IPv4. Okay, and here the flow label is nothing but you can label the packets, okay, according to its flow.